Antarctica is a land of extremes, coldest, driest, and highest on Earth, a place where the sun can shine for months on end or disappear for weeks into endless night. Its vast frozen expanse stretches further than most people imagine, covering an area nearly twice the size of Australia. The continent is dominated by a colossal ice sheet, a blanket of ice so thick it holds nearly 60% of the world's fresh water, locked away in a frozen vault. For centuries, this frozen mask has hidden a complex world beneath, mountains, canyons, and vast lakes, unseen by human eyes for millions of years. Beneath the ice, ancient landscapes are preserved, untouched since the time of the dinosaurs, waiting to be revealed. The ice is not static. It moves, shapes, and preserves the land below. Glaciers flow like slow rivers, carving valleys and shifting the very ground beneath them, their movement both relentless and mesmerizing. Our early knowledge was limited to rocky outcrops at the edges, leaving the continent's true nature a mystery. Explorers could only guess at what lay beneath the endless white, piecing together clues from the few exposed rocks. Unlocking this hidden world is a scientific adventure, crucial for understanding our planet's climate. Each ice core drilled is a time capsule, revealing secrets of Earth's atmosphere and climate stretching back hundreds of thousands of years. The shape of the land beneath dictates how ice flows to the sea, impacting global sea levels. Even small changes in the hidden landscape can alter the fate of glaciers and the oceans they feed. As the world warms, the stability of Antarctica's ice sheet becomes a question for all humanity. The fate of distant cities and coastlines may depend on what happens here at the bottom of the world. These secrets are not just Antarctica's, they affect us all. The story of this remote continent is deeply connected to the future of every person on Earth. Modern explorers use advanced technology to map this invisible landscape, venturing into one of the harshest environments on Earth. With radar, satellites, and remote sensors, they peel back the layers of ice to reveal the hidden world below. Each new discovery adds detail to a map that is transforming our understanding of the continent. Every data point brings us closer to seeing Antarctica as it truly is, a place of wonder, complexity, and change. Antarctica is revealed not as a simple white desert, but as a dynamic world with a dramatic past and an uncertain future. Its story is still being written, shaped by forces both ancient and modern. The quest to uncover its secrets is like mapping another planet, right here on Earth. And as we continue to explore, we realize that the fate of this distant land is tied to our own. How do you map a continent you cannot see? Scientists use radar, sonar, and satellites to peer through miles of ice. Aircraft equipped with ice-penetrating radar fly grid patterns, mapping the land below with precision. Gravimeters and magnetometers reveal the type of rock hidden beneath. Ships with sonar systems chart the seafloor, discovering canyons and channels that guide ocean water under the ice. On the ground, teams tow radar sleds for high-resolution surveys of key areas. All this data from sky, sea, and ice combines to create a detailed picture of Antarctica's hidden world. These efforts are painstaking but essential for understanding how the continent works. Piece by piece, the invisible landscape is coming into focus. The BedMap 3 project is a monumental international effort, bringing together scientists from around the globe to unlock the secrets beneath Antarctica's vast ice sheet. This collaboration spans multiple countries and disciplines, uniting glaciologists, geophysicists, and climate experts in a shared mission. Their goal is to create the most detailed and comprehensive map ever made of Antarctica's hidden terrain, revealing features that have remained unseen for millions of years. The project compiles millions of data points collected over decades using advanced radar, sonar, and satellite technology to peer through the thick ice and capture the landscape below. This data reveals not only the surface of the ice, but also its thickness, the contours of the bedrock, and the hidden valleys and mountains that shape the continent. The result is a high-resolution, three-dimensional portrait of the subglacial continent, offering an unprecedented look at what lies beneath the ice. BedMap 3 reveals that West Antarctica is actually a vast marine basin, much of it lying below sea level, and making it especially vulnerable to changes in ocean conditions. In contrast, East Antarctica stands as a high, ancient landmass, its rocky terrain rising above the surrounding ice and ocean. Deep troughs and sprawling basins channel massive rivers of ice toward the coast, acting as pathways for ice to flow from the interior to the ocean. The precise mapping of the grounding line, the point where the ice sheet meets the ocean, is crucial for predicting how stable the ice sheet will remain in the face of warming temperatures. Many of these grounding lines are found in deep, reverse-sloping troughs, which can accelerate ice loss if destabilized. These areas are particularly vulnerable to incursions of warm ocean water, which can cause rapid retreat of the ice and contribute to global sea level rise. The detailed information from BedMap 3 is vital for climate models, allowing scientists to make more accurate forecasts of future sea level rise and its potential impacts on coastal communities worldwide. With this new map, researchers can simulate the flow of Antarctic ice with unprecedented realism, improving our understanding of how the ice sheet will respond to a warming world. BedMap 3 fundamentally changes our ability to predict Antarctica's future and its far-reaching impact on the entire planet. From ocean circulation to weather patterns, it's a leap forward in understanding our changing planet and a crucial tool for safeguarding the future of our world. Modern science reveals Antarctica's hidden landscape as dramatic as any on Earth. East Antarctica is a high plateau with mountain ranges. West Antarctica is a collection of islands and deep basins much below sea level. If the ice melted, West Antarctica would become a vast archipelago. Enormous canyons and valleys rivaling the Grand Canyon were carved by the grinding movement of ice over millions of years. These troughs funnel ice to the sea, making their mapping key to predicting ice loss. Over 400 subglacial lakes have been found, connected by hidden rivers that lubricate the ice sheet's base. Most astonishing are entire mountain ranges, buried and unseen for millions of years. Once mere speculation, these ghost mountains have been revealed by radar surveys. Their discovery rewrites Antarctica's geological history and adds new wonders to our world map. Deep beneath the thick frozen expanse of East Antarctica's ice lies a secret world, the Gamburtsev subglacial mountains. This mysterious range, as large as the European Alps, has remained hidden from human eyes for millions of years, entombed beneath more than a mile of solid ice. For centuries, no one suspected such a dramatic landscape could exist in what seemed to be a featureless, icy desert. The first clues came in the 1950s, when a Soviet research team detected strange anomalies beneath the ice. Their findings sparked decades of curiosity and international collaboration, as scientists from around the world joined forces to uncover the truth. Only with the advent of advanced technology and persistent effort did the true scale and grandeur of the Gamburtsevs finally come to light. Stretching an astonishing 750 miles, with jagged peaks soaring over 9,000 feet, the Gamburtsevs would rival the world's most iconic alpine landscapes, if only they were visible above the ice. Their hidden summits and deep valleys are as dramatic as any on Earth. The sharp, youthful appearance of these peaks baffled geologists. How could such rugged, seemingly young mountains exist in one of the planet's oldest and most stable regions? The mystery deepened as more data was gathered. Through radar surveys and seismic studies, scientists discovered that the Gamburtsevs are ancient, formed over 1 billion years ago. Over time, they were worn down by erosion, then uplifted again by powerful tectonic forces, and finally sealed beneath the ice, perfectly preserved. Around 34 million years ago, as the climate cooled, a massive ice sheet swept over the mountains, flash freezing the range and locking its alpine features in place. The ice acted like a protective shield, preserving the mountains in a state of suspended animation. Scientists now believe the Gamburtsevs played a crucial role in the birth of the East Antarctic ice sheet. Their high peaks provided the perfect place for snow to accumulate, allowing glaciers to form and spread outward, eventually covering the entire continent. The discovery of this hidden range not only redrew the map of Antarctica, but also helped solve the riddle of how such a vast ice sheet could have formed in the first place. It was a breakthrough that changed our understanding of the continent forever. These ghostly peaks, preserved in the deep freeze, are a key to unlocking the secrets of Antarctica's icy origins in the planet's ancient past. The story of the Gamburtsevs is a testament to the power of human curiosity, exploration, and technology, reminding us that even in the most remote corners of our world, there are still wonders waiting to be discovered. Lake Vostok, Antarctica's largest subglacial lake, lies sealed beneath 2.5 miles of ice. It's as large as Lake Ontario, isolated for millions of years, no sunlight, no contact with the surface. The lake exists thanks to insulation from the ice above and geothermal heat below, keeping the water liquid. Its isolation makes it a natural laboratory for studying life in extreme environments. Russian scientists drilled for decades to reach it, finally sampling its waters in 2012. Traces of microbial DNA suggest life may exist in this dark, cold world. If confirmed, it would prove life can persist in the most hostile corners of our planet. Lake Vostok is a window into Earth's past, and perhaps, into life's possibilities elsewhere. Antarctica's hidden valleys and canyons extend beneath the ocean, acting as highways for warm water to reach the ice sheet's base. This process accelerates ice loss, as warmer water melts the ice from below. Thinning ice shelves act as corks. When they weaken, glaciers flow faster into the sea. Meltwater from Antarctica affects global ocean currents, influencing climate worldwide. The cold, dense water formed here drives the planet's ocean conveyor belt, distributing heat and regulating weather. Changes in Antarctic meltwater could disrupt this system, with far-reaching consequences. Mapping these canyons is essential for predicting which parts of the ice sheet are most at risk. Understanding these features helps us forecast future sea level rise and climate change. Unveiling Antarctica's hidden world is vital for predicting our planet's future. The ice sheet holds enough water to raise sea levels by nearly 60 meters. Its stability depends on the land beneath. High-resolution maps reveal the fastest routes for ice to reach the sea, improving climate models and forecasts. This knowledge helps policymakers and communities prepare for rising seas. Meltwater from Antarctica also influences ocean salinity and currents, affecting global weather patterns. The buried landscape preserves millions of years of Earth's history, offering clues to past climate changes. Studying these features helps us distinguish natural cycles from human impacts. Antarctica's secrets are keys to understanding both our past and our future. The more we learn, the better prepared we are for what lies ahead. Exploring Antarctica's subglacial world expands our understanding of life's limits. Lakes like Vostok, sealed for millions of years, are among Earth's most extreme environments. If life exists here, it proves organisms can survive in darkness, cold, and crushing pressure. This has profound implications for the search for life beyond Earth. Moons like Europa and Enceladus may have similar hidden oceans. Antarctica is a testbed for the technology and methods we'll use to search for life elsewhere. Any microbes found here would be extremophiles, with unique biology and survival strategies. Studying them could lead to breakthroughs in science and medicine. Antarctica's hidden world is not just a scientific frontier, it's a window into our planet's climate, history, and the potential for life in the cosmos. As we continue to explore, we're not just mapping a lost continent, we're redefining our place in the universe. The greatest discoveries may still await deep beneath the ice.